All right, here we go with Module 1, Lesson 12. And this lesson has a funny word. It's multiplying using estimation to determine reasonableness, which sounds kind of crazy, but basically it's saving you time in math because it's going to get your brain to start thinking about whether or not it's even reasonable to get the answer that you're getting. So let's think a little bit about what that looks like. Suppose I was looking at 31 times 4, and I had to do it in an area model. Well, I told you that the 4 goes here, right? And I have 3 10s and 4 ones. And then I would do 3 times 4 is 12, and 4 times 4 is 16. So that gives me 12 tens, which is actually 120, right? 12 tens is 120. And 16 ones. Oh, this 4 doesn't go here. This is a 1, right? 31. 1 times 4 is 4, which leaves me with 4 ones. Well, 120 plus 4 equals 124. Well, if I think about that, as far as reasonableness, I think, what is 3 times 4? 12. So my answer should be somewhere in the vicinity of, if I went 30 times 4, which would be 120, my answer should be somewhere around 120. This is in the tens. My answer should be in the tens or larger, right? Not anything smaller. Let's try the same problem with 3.1 times 4. Well, if we were doing that exact same area model, I'm just saying 4 here, 3 here, 1 here, only this time this is in the ones place and this is in the tenths place, right? That's the only thing that changed. The numbers are all the same. 3 times 4 is 12, only this time it's not 12 tens like it was here, it's 12 ones. And 4 times 4 is 1. 4 times 1 is 4. Okay, so I still have 12 ones is 12. 4 tenths is 4. My answer is still 124, right? I still have 124. But I need to know that, look at, my decimal point was 1 place over, right? So I'm not going to get something that's, I'm not going to get an answer that's smaller than 1's place. I need to get an answer that's actually probably going to be 1's or larger. So I'm thinking 3 times 12, that would put me up much closer. 3 times 4 would put me much closer to 12 than it would to anything in the 1's place, right? So the same would be said if I had 31 hundredths times 4. The area model just goes again. Oops, I should give myself more space. The area model goes the same again, right? I still have a 3, I still have a 1, I still have a 4. This is still going to be a 12. This is still going to be a 4. Only this time this was in the tenths place, and this time this was in the hundredths place, right? So this is 12 tenths. 12 tenths. Well, 12 tenths actually looks like that, doesn't it? Because the 2 has to be in the tenths place and the 1 would be in the ones place. Let me fix my page so you can see it good enough. And then this is actually 4 hundredths. If I added 12 tenths plus 4 hundredths, my answer would be 1.24. So notice that the 124 is the same every time, and it's the decimal point that is shifting every time. Here's another way to look at what I'm saying. Suppose the problem said 5.1 times 6. Okay, I very easily would know how to multiply 51 times 6, right? But I just have to remember that my 51 is actually in the tenths place. 6 times 1 is 6. 6 times 5 is 30. So 51 times 6 is 306. But since it was in the tenths place, then my answer has to be in the tenths place. Now, I'm going to use my place value chart to really think about, I can't remember. To really think about what 306 tenths looks like. That means that my 6 has to be in the tenths place, right? 306 tenths really looks like 30.6. So it's wise to use your place value chart to go ahead and write the number out. I have 306 tenths. That means that my 6 has to be in the tenths place. Or another way to think about that is tenths is just 1 decimal point over, right? Tenths means 1 decimal point over from the end. So when you're looking in the problem set, it tells you to do 2 things. 1, choose the reasonable product. They're just saying, no matter what, your answer is going to be a 1 or 10 or 100. No matter what, you're going to have a 1 in your answer. But what place value is your 1 going to be in? So 1, you choose the right one. 2, explain yourself using words, pictures, or numbers. Okay? So what I'm looking at right here is 25 tenths times 4. 25 times 4 would be the same as 4 quarters, right? 25, 50, 75, 100 tenths. If I did 100 tenths, I told you tenths means 1 place value over, right? The decimal point just is over once. You could always use your dry erase to really check if that's true. 100 tenths. Tenths is the place value I said, so I'm going to make my last number in the tenths. 100 tenths is actually what? 10. 100 tenths is actually 10. Now let's use words to explain that. 25 tenths times 4 equals 100 tenths, which is 10. Therefore, it would not be reasonable to get 1/10 as an answer. It would not be reasonable to get 1/1 as an answer. It is reasonable to get tens as an answer, but 100 is not a reasonable answer because this answer doesn't say 100. It says 100 tenths. And again, when I put 100 tenths on a place value chart, that's actually 10.